Doing laundry used to be foolproof. Now it feels like gambling with your wallet. The official story is progress. More features, more savings, smarter machines. But hidden behind shiny touchscreens and plastic parts, washers and dryers in 2025 are engineered to break, often years before you expect, and exactly when it hurts most. Why would brands do this? And how deep does the rabbit hole of planned obsolescence go? The answers may change what you buy next. Courtrooms and patent offices aren't the first places you'd expect to find the secret life of your laundry machine, but the evidence is hiding in plain sight. Legal filings from the past decade paint a picture that's less about honest mistakes and more about calculated design. In 2013, a class action lawsuit against LG and Sears landed in federal court, spelling out how certain top-loading models were defective by design. Not just fragile, but engineered to vibrate so violently that internal parts shook themselves loose. The fix was not a new part, but a software update that simply capped the spin speed, sacrificing cleaning power for the illusion of safety. The machines kept breaking. The documents are blunt. The defective washing machines have the same inherent design defects that cause them to shake and vibrate excessively, and cause internal parts to come loose. The U.S. Consumer Product Safety Commission recall files back up these claims. In 2012, nearly 500,000 LG and Kenmore washers were pulled from homes after reports of hardware detaching mid-spin, sometimes with enough force to damage the machine or the laundry room itself. These were not isolated events. Samsung's infamous 2016 recall involved 2.8 million top loaders after dozens of reports of exploding lids. Internal quality control warnings revealed later show that managers knew about the risks but delayed public action for months. Russian roulette. I never thought I'd risk head trauma for cleaner socks. Patent filings round out the paper trail, and they read like a blueprint for early retirement of your washer, not you. Between 2005 and 2018, major brands filed patents for integrally molded plastic assemblies, sealed tubs, and modular transmissions that cannot be repaired without replacing the entire unit. These documents tout 30 to 45% manufacturing cost savings by swapping steel for glass-filled nylon gears and snap-fit plastic supports. The catch: plastics under vibration fail in 2 to 5 years, while steel equivalents last decades. Manufacturers get to pocket the savings. You get to schedule the service call. Repair advocates and technicians have been waving red flags for years. Old Maytags survived floods. New ones barely survive spring cleaning. Service bulletins reveal another layer. Parts for older serviceable models are discontinued early, pushing owners toward full replacements when a single plastic gear cracks. Whistleblower statements in legal complaints describe engineers pressured to meet cost targets by lowering component specs and skipping endurance tests. The result? Machines built to the minimum, not the maximum. All these breadcrumbs, from lawsuits, recalls, patents, and technician testimony, lead to one conclusion. Modern washers are not just unlucky. They are designed to keep you buying, not to keep running. The evidence is not buried in some secret vault. It is stamped right on the legal documents and patent diagrams. And it is the reason repair shops are busier than ever, while warranties keep getting shorter. Smart washers promise to make laundry effortless, but in reality they're more like a digital soap opera with a cast of unreliable characters. The main villain? Control board. In the past, a broken washer meant a worn-out belt or a leaky hose. Today, a tiny circuit board can cost as much as a weekend getaway. Warranty data from Square Trade and Asurion lays it out in cold numbers. Electronics now fail 3 times as often as old-school motors and pumps. That's not a typo. A technician in Chicago tells it best. He gets a call from a panicked customer. Her 2-year-old LG washer, barely out of warranty, won't unlock. The culprit was a power surge that fried the board. The fix wasn't a $40 switch or a new latch. It was a $380 circuit board swap plus labor. The machine itself only cost $700. The technician shrugs. He's seen it 100 times. In the old days, I'd carry a few belts and some pliers. Now I need a laptop and a prayer. These boards aren't just expensive, they're sensitive. A minor voltage spike, a little moisture, or even a software glitch can send a modern washer into a tailspin of error codes and locked doors. Some machines freeze mid-cycle and refuse to budge until a technician resets the firmware. Others throw cryptic error messages that even the manufacturer's helpline can't decipher. The problem isn't limited to one brand. LG's infamous EBR-86498A02 board is the poster child. But Samsung, Whirlpool, and GE have all had their share of electronic meltdowns. The math is brutal. For every $100 spent on a smart washer, a growing chunk is just insurance against its own electronics. Warranty periods shrink. Extended service plans become a necessity, not a luxury. And when the board dies just after the warranty expires, most owners face a choice: shell out for a pricey repair or buy a new machine. For repair shops, it's a gold rush. For everyone else, it's a headache. Technicians say the real problem isn't user error or bad luck. It's the design. More sensors mean more points of failure. More software means more things to crash. The industry calls it innovation. Owners call it a roulette wheel with a spin cycle. And every year, the odds get worse. Front-load washers entered the market with a promise: cleaner clothes, less water, and a sleek, modern look. The reality? For every gallon saved, there is a new headache waiting behind the door seal. On paper, front-loaders are the environmental hero, using as little as 10 to 15 gallons per cycle, compared to 20, sometimes even 30 gallons guzzled by a traditional top-loader. The Department of Energy statistics do not lie. If you are counting every drop, a front loader can shave thousands of gallons off your water bill over its lifetime. But that is only half the story. Ask any repair tech about front loaders and they will tell you about the dark side, the infamous door gasket. That thick rubber seal designed to keep water in also traps stray sock fibers, soap scum, and every drop of moisture. Over time, it becomes a perfect breeding ground for mold and mildew. Complaints started rolling in almost as soon as the first models hit American homes. By 2010, class action lawsuits were stacking up against Whirlpool, Maytag, and others, all pointing to the same musty, sour odor that no amount of bleach or vinegar could fix. Manufacturers scrambled to redesign seals and add cleaning cycles, but the stench lingers in tens of thousands of laundry rooms. Then there is the sensor drama. Front loaders pack in more electronics, more sensors, and more error codes than a spaceship. Slightly uneven load. Error. Forgot to wipe the seal. Error. Door did not close with the right amount of force. Error. The machine refuses to start, or worse, locks itself mid-cycle, holding your clothes hostage until a technician resets its digital brain. Warranty data from the past decade shows front loaders are twice as likely to need service for sensor or control board failures compared to their top-load cousins. Top loaders, on the other hand, are the sturdy workhorse of the laundry world. They use more water, sometimes twice as much as a front loader. They are louder, they vibrate, and they do not win any design awards. But they just keep going. The parts are simple. There is no door seal to trap moisture, so mold and mildew are rare guests. Error codes? Barely any. If something breaks, it is usually a belt or a pump, parts that cost less than a nice dinner. Some models still come with a mechanical dial and a heavy steel tub, making them nearly impossible to kill. Repair techs joke that you can run a top loader with a brick in it, and it will finish the cycle, no questions asked. Of course, top loaders are not perfect. They are not as gentle on clothes, and their appetite for water is not great for drought-prone areas. High-efficiency top loaders have tried to close the gap, dropping water use to 15 to 25 gallons per cycle, but they still cannot match the frugality of a front loader. Still, the trade-off is clear. You get a machine that is simpler, sturdier, and far less likely to throw a digital tantrum. Choosing between front load and top load is like picking your battles. Do you want a quiet, water-saving machine that might develop a personality disorder after 3 years? Or do you stick with the noisy, thirsty workhorse that shrugs off abuse but will not win any beauty contests? In the end, the real gamble is not just about water or energy. It is about how much frustration you are willing to risk every time you hit the start button. A washing machine used to be a hunk of metal with a motor. Now it's a plastic puzzle box with a timer. The difference shows up in your wallet, not just your laundry room. Manufacturers love to brag about advanced polymers and engineered plastics, but the numbers tell a less glamorous story. Switching from steel to plastic for key parts like gears, couplers, and even the tub cuts production costs by up to 45%. That is not a small trim. That is a haircut. Appliance materials consultants say a steel gear that costs $4 to make can be swapped for a plastic version at less than half the price. Multiply that by millions of machines, and you see why the industry is hooked. But here is the catch. Plastic does not just save money for the factory. It costs you, the owner, every time something snaps. Real-world service data is blunt. Polymer gears and assemblies last around 2 to 5 years before they crack, warp, or just give up. Steel equivalents keep spinning for 10 to 20 years, sometimes longer. It is not just theory. Repair shops see a parade of busted plastic couplers and shattered transmission gears, especially in machines built after 2010. The parts themselves might only run $40 to $150, but labor and diagnostic fees quickly stack up. A typical repair lands somewhere between $250 and $400. For high-end models, it is not unusual to see a single repair bill hit $600 or more, sometimes half the price of a new washer. The economics get even uglier when you factor in part scarcity. Plastic-heavy models are infamous for early discontinuation of replacement parts. After 5 or 6 years, that $80 gear might not be stocked anywhere but a third-party warehouse. If you are lucky. If not, you are looking at replacing the entire transmission, or worse, the whole machine. Owners often hit a wall, pay a premium for a repair that may not last, or just buy a new washer and start the cycle over. That is not an accident. It is the business model. A materials consultant put it plainly. Cost optimization does not always mean consumer optimization. Sure, plastics are lighter, easier to mold, and do not rust. But they hate vibration and heat, which is exactly what you get in a spin cycle. The result is more frequent breakdowns, more service calls, and a lifetime cost that keeps climbing with every repair. Warranty data backs this up. Mainstream brands with plastic internals see a spike in failure rates after just 3 years, while premium or commercial models built with steel keep churning for decades. Some repair techs even joke that every plastic part is just a ticking clock, counting down to your next bill. The real math of owning a modern washer is not just about the sticker price. It is the total cost of repairs, downtime, and replacements over the machine's short lifespan. That $600 bargain at the big box store can easily become a $1,200 headache by year 8. Meanwhile, a steel-heavy washer, think Speed Queen or old-school Whirlpool, may cost more up front, but keeps your money in your pocket for the long haul. So the next time a salesperson brags about advanced composites, remember, you are not just buying a washer. You are buying into a cycle of repairs, one cracked gear at a time. Samsung washers are the runway models of the laundry world. Flashy, loaded with features, and prone to dramatic meltdowns. The 2016 recall sent 2.8 million machines back to the shop after lids started launching like frisbees. Error codes and noise complaints still haunt their reputation, though recent models show some improvement. LG, on the other hand, wins awards for cleaning and runs whisper quiet. But when something breaks, prepare your wallet. Their circuit boards are notorious for failing just after the warranty, and repairs can cost half the price of a new machine. Repairs that hurt. Whirlpool holds on to its old-school reliability, especially if you stick with the basic top-load models. Add a touchscreen or Wi-Fi and the odds of a repair ticket jump. GE was on the ropes a decade ago, but their engineers staged a comeback, ditching gimmicks for sturdy builds and mold-resistant seals. Service rates are still higher than the best, but trending in the right direction, more solid than before. Maytag's commercial-grade machines are the last of the manual knob workhorses built to take a beating. But some residential models are just rebranded Whirlpools. Check the guts before you buy. Amana keeps it simple and cheap, using Whirlpool parts in a no-frills package. Not exciting, not cutting edge, but they get the job done. Then there is Speed Queen. A worker on the line once joked, "We stamp our steel thick enough to double as tornado shelter panels." These machines are built to outlast your patience. Manual controls, steel guts, and a 7-year warranty that makes the rest of the industry blush. If you want a washer that just works, that is the gold standard. Shopping for a washer or dryer shouldn't feel like prepping for a courtroom cross-examination, but here we are. The rules have changed, and the only way to win is to stay skeptic. First, skip the touchscreen panels. If you want a machine that lasts, look for manual dials and buttons. More electronics mean more things to break. Repair data shows that old-school controls outlive their flashy cousins by years. Second, check the drum. Stainless steel is your friend. It shrugs off rust and lasts longer than plastic, especially when the machine goes off balance. Third, ask about the transmission and gears. If the salesperson can't say if they are metal, assume they are plastic. Industry estimates say plastic gears save factories up to 40% per part, but they'll cost you in repairs within 5 years. Assume plastic. Fourth, keep it simple. You don't need 40 wash cycles, just a handful that actually work. More options are just more things to go wrong. Fifth, check the warranty. A real warranty covers 5 years or more on the core parts, not just a single year of limited coverage. Short warranties are a red flag. Finally, check the label. Machines assembled in the US or Europe tend to use sturdier parts and get better support. The best luxury is a washer that makes the laundry boring again. Quick, reliable, invisible. Real luxury is a machine you never have to think about. That is the goal. In the past 2 decades, the average lifespan of a washing machine has dropped from 15 to 25 years to just 7 to 10, according to industry repair data and warranty claims. Legal filings and patent records from 2005 to 2018 show a clear shift toward plastic parts and complex electronics. Choices that have increased failure rates and repair costs for consumers. Despite mounting evidence of planned obsolescence, many internal design documents remain sealed or redacted in court cases, leaving some motives unconfirmed. Today, field reports confirm that most repair calls now involve failed circuit boards and sensors, not worn-out motors or drums. The facts are simple. Brands that focus on durability and basic controls, like Speed Queen and Maytag Commercial, still deliver machines that last. As of 2025, the pattern is clear. Real reliability comes from proven materials and straightforward engineering. The evidence shows that rewarding companies who build for the long haul, not for quick upgrades, is the only way to protect your investment.